a lot of people. Sorry for taking time to make the video. So what I'll be doing in this video, we are starting with electricity, right? I wanted to do it all in one video, but I think that's not a good idea. First, I want to see if you can apply the basics, and then from there you are going to go to a bit challenging things. Because to be honest with you, the only thing that they introduced in grade 11 when it comes to electricity is the internal resistance, right? So that's the only thing that is new. But for you to be able to understand the internal resistance and everything, you must first understand the basic electricity. So we know that electricity in simplest terms is just movement of what? Movement of charge, right? It is basically movement of charge. And we know that electricity, there are three main important things that we are components that we are focusing on. Number one, we are focusing on current, right? Number one, we are focusing on the current. Number two, we are focusing on the resistance. And number three, we are focusing on the voltage or the potential difference, right? And we know that all of these three things have SI units. So the SI units for current is amperes, and then the resistance is ohms, and then for voltage, it's volts, right? And don't confuse voltage with EMF, right? Which is indicated by that symbol, right? So it's also the units for EMF is volts, it's V, right? But the difference between the EMF and the potential difference is that in EMF, we measure it in an open circuit, right? We measure it in an open circuit, whereas the voltage, we measure it in a closed circuit. When the circuit is closed, that's when we have the terminal voltage or the potential difference. And then when it's open, that's where we have the EMF, right? So you will see that we'll talk more about the differences between the two when we do the internal resistance. So what I wanted to know also, when we're talking about electricity, we everything that they'll be asking you concerning to electricity will be based on the circuits. So we have two types of circuits. We have the series circuit, and then we have the parallel circuit. All this, what it simply means, it's basically focusing on what? It's basically focusing on the connection of the resistors, connection of the resistors. So when the resistors are connected in parallel to each other, we call that a series circuit. When they're connected, parallel to each other, we call that a parallel circuit. When they're connected in one conductor, because we all know what a conductor is. You did all those differences between a conductor and an insulator and all those things back in grade 10. So I won't waste your time on that, right? So now what I want you to know is for us to explore the differences between the two, because if you can master that, then there's nothing that is going to give you problems when you're doing electricity, right? So first, to start with, I'll just tabulate the differences between the two. We have the series circuit and then we have the parallel circuit. So the first thing that I want you to know is how do you see the difference between the two? Because no one is going to tell you whether you're looking at the series or the parallel. They're just going to throw a circuit for you, and most of the time they're going to combine them. They're going to combine the series and the parallel into one circuit, right? So you should be able to tell the difference. So when we say that series, when we say resistors are in series, we mean that they are connected in one conductor, meaning that you know that we have the cell, right? I won't tell you what the cell is, you know that. So from there, let's say we have the first resistance here, and then we go on, and then we have the second resistance there, and then we come back, right? Let's say there we have our current there, right? So this is resistor 1 and this is resistor 2, right? And then let's say across there we have our voltage, right? So a basic circuit looks something like that. So now what we have to know is that resistor 1 and 2, we say that they are in series because they are not divided by anything. They are in one conductor. By one conductor, I mean one line. You see, I'm drawing this line going straight and it's coming back to that one, right? But when resistors are in series, it's when you have another, let's say we have resistor 3 somewhere there, right? Then it comes back. So you can see that these two, they are not shared by one conductor, because when this conductor gets here, this one is going there and that one is going there. It's divided, right? So when we're saying that things are in parallel, resistance 3 and 2 are in parallel, but resistance 1 and 2 are in series. And when you add resistance 3 and 2, you will get the resistance in total. So at the end, you'll be having something, resistance 1, and then have the resistance total of parallel, right? And then from there you have your current, and then you still have your voltage across them, right? So if I was to add these two resistances, we have something like this, right? But just know that resistance 2 and 3 are in parallel. So there are certain things that I want you to know. Now that you know how do you see how do you separate the series from parallel, right? So now, few things that I want you to know to start with. Number one, the series is also known as potential dividers, right? Or not potential dividers, voltage dividers, right? It's also, the series circuit is also known as the voltage divider. And then the parallel circuit is also known as the current divider. And I'm going to explain why. Reason being, when you are in series, when you are in a series circuit, when you are in a series circuit, the current is the same. Current is same everywhere, meaning that the total current of the circuit will be the same as the current of one or the current two or whatever. It's the same everywhere. But when we are coming to the parallel circuit, voltage is the one which is the same everywhere, right? So meaning that the total voltage will be equal to the voltage in one. And I'm going to show you in terms of the actual diagrams, right? And then also another important difference. This one is very, very important. You should know this one. Another important difference is that when we are calculating the total resistance in series, the formula we use is total resistance is equal to resistor 1 plus resistor 2. But when resistors are connected in parallel, we say 1 over resistors are in parallel plus 1 over resistor 1 plus 1 over resistor 2, right? And then at the end, let me do an example. Let's say resistor 1 and resistor 2. Maybe resistor 1 is 2 and resistor 2 is, let's say, 4. Right? So you would have to add this 1 over 2 and 1 over 4. We know that the common denominator is 4. So 2 into 4 is 2 times 2 is 2 plus 4 into 1 is 1 times 1 is. So this would be 3 over 4. But this 3 over 4, remember, it's still 1 over parallel, right? It's still something like this. And we want the total. So what you will do the inverse, right? Or you'll simply cross multiply, right? It's one and the same thing. So what you'll do is say, total resistance is equal to take this to the upside, this down. So the total resistance is actually 4 over 3. So that is what you have to know when it comes to the parallel, right? Don't mix up things. I hope that makes sense and I'm not confusing you. So now what I want you to do is to master these differences. So let's assume that they give you a circuit, and the circuit is something like this, right? Let's say we have the first resistance there. We have another resistance there, we have another resistance here, something like that. Then let's say we have our amperes, and then we have, let's say we have voltage here, V2, let's call it V2, and let's call this one here V3, right? And yeah, let's say here we have another amperes, right? This is, we call this 1, we call that one 2, right? And then we have voltage 1 there, right? We have something like this. Yeah, I want to show you something. So now you listen to me. What is going to happen? We have resistor 1, R1, we have R2, we have R3. What you have to notice here, based on what I've told you so far, we know that these two are in parallel, this one is series. So it means they took a parallel and a series circuit, they combined them, right? This is what they will do most of the time. They won't just bring one circuit that is only series, right? This is what they will do. So if they say to you, calculate the total resistance, let's say this one is 2 ohms, let's say this one is 4 ohms, and let's say this one is 3 ohms, right? For you to be able to calculate the total resistance, you know that this one and this one are parallel to each other. So you should say 1 over resistance in parallel is equal to 1 over resistance 1 plus 1 over resistance 2. You should write that formula. But now I won't do that because we know it's 4 plus 1 over 3. You get the total resistance. Remember, at the end, you must swap, right? the numerator must be the denominator. After getting that, the total resistance of the circuit will be the resistance of the parallel plus the resistance of the series, which is only this one, right? So it will be just plus R1. The one you will get here is the resistance in total, right? And then if they say to you, calculate A2, right? A2 is in series. A2 is in series because it's one conductor. It's moving from there all the way to there. So for you to get A2, for you to be able to get A2, what should you do? For you to be able to get A2, you will use the total voltage of the whole circuit and the total. So for you to get A2, okay, here's another thing that you should do. We have a special triangle that you should do, right? We have voltage here, we have current there, and then we have resistance there. So the one that you always want is the one that you will hide. In this case, we want to add current. So we'll hide current, so it will be voltage over resistance. If you want voltage, it's current multiplied by resistance. If you want resistance, it's voltage divided by current, right? But now we want current, so it will be voltage divided by what? By resistance. The voltage we will use is the one, let's say they gave you that the voltage here is, let's say 12 volts. Let's say they gave you 12 volts, right? So you'll say 12, but you must first write this formula that I is equals to V over R, right? And then from there, what you will do, you will then divide this voltage by what? By the total resistance you got. That's how you get A2. And then how do you get A1, right? How do you get A1? A1, you get A1, you can see that A1 is here. So A1 won't be the same as A2, right? But if they said, let's say we have A3 here, I want to see if you really understand what I'm saying. If we have A3 here, right? A3 will be the same as A2 because they are in series, right? A1 won't be the same as A2 and A3 because it's in a parallel circuit. And we said that in the parallel circuit, the current is not the same, right? So for you to be able to get A1, you won't touch this resistance. You don't touch this resistance because it's not part of this, right? So for you to get A1, you must first get the voltage of this part, right? And then after getting the voltage of that one, and then you get what? Let's say they told you that the voltage of this one is 6 volts, right? So if V2 is 6 volts, it means V3 will also be 6 volts because they are parallel to each other. They will be the same. I hope that I'm making sense, right? So from there, if you have 6 volts, then it means that the current, the total resistance that we use, it's this one, not this one. So that is how you'll be able to get A1, which is your current. I hope that makes sense, right? So all I was trying to show you here is to show you how they combine these things and how they can sort of try to confuse you with all of these things. So I don't want the video to be too long because I realize that when the videos are too long, you take time to download them and you take time to respond. So I will just cut it here. I will send you exercises. You do those exercises, you come back, and then from there, I will be able to gauge whether you are ready or not for us to move to the last session, right? So that will be it for this video. Thank you.